Welcome back to Easy as Pie, the channel that makes maths simple. If you're new to the channel, make sure you hit that subscribe button so you don't miss any new content. Today we're going to be covering the Level 2 NCEA Algebra paper. Part A. Simplify fully 25m to the power of 16 all to the power of 1/2. So for this question here, all you have to go about doing is follow this rule here. So if you've got a to the power of n and b to the power of x, for example, and that's all to the power of y, we just times the powers together like so. So it'll be a to the power of n times y multiplied by b to the power of x times y. So what I do to start these is I usually put the power on the number so I don't forget it has one. So 25 with no power is just 25 to the power of 1. Then I start timesing the power through, so 1 times a half is a half, so it'll be 25 to the power of 1/2, and then half times 16 is m to the power of 8. 25 to the power of a half is the same as a square root, so anything to the power of a half is the same as a square root, so the square root of 25 is just 5, and then that's multiplied by m to the power of 8. I'm going to show you a wee trick just to know that you've done it correct in an exam situation, which is very handy. So let's just go back to what we started with, which was this here, 25m to the power of 16 all to the power of 1/2. And we're saying that it should simplify down to 5m to the power of 8. So a way we can check this is if we pick any value for m and plug it into here and calculate the answer, and put the same value for m into here and calculate the answer on our calculator, if the same result comes out for this and for this, we know that it's going to be correct. So let's just pick an m value. Let's try 2. Right, let's try it for the original before we simplified it. So we're going to have 25 multiplied by 2 to the power of 16, and all of that to the power of a half. And then we're going to see if that equals, if we put m as 2 into here, 5 times 2 to the power of 8. And we'll get a calculator up to go through the calculations. Right, so the first one here, we've got 25 multiplied by 2 to the power of 16, and all of that, so we're going to bracket that all up, all of this is to the power of 0.5, and we get an answer of 1280. If we try the other part over here, we should get the 1280 out, so let's have a look. 5 multiplied by 2 to the power of 8, and again we get 1280. So we 100% at this point know that it's most likely correct. Again, this step is not necessary here, that's just checking that it's correct. This answer here is the one that will get you the full marks, and this question will gain you an achieved mark. Part B. Simplify fully 4 over 3a all to the power of -2, leaving your answer with a positive index. So that's just meaning with positive powers is your final answer. How we're going to go about this is we're going to look at this rule here. So if I have a over b all to the power of n, it's equivalent to a to the power of n over b to the power of n. So we're going to start with that rule. So I'm going to rewrite this part here as 4 to the power of -2 over 3a to the power of -2. And again, we're going to start to use that rule that we just used in part A. I'm going to put powers on everything. There are no powers on the 4, the 3, or the a, so that means they all have powers of 1. And we just times the power through. So -2 times 1 will give me 4 to the power of -2 on the top. And on the bottom, -2 times the 1 there will give me 3 to the power of -2. and negative 2 times 1 will give me a to the power of negative 2. Right, a step from there is anything with negative powers, you can swap them where they are on the fraction. So if they've got negative powers and they're on the bottom, you just put them to the top and make the power positive. Similarly, if you've got it on the top, like the 4 here, you can bring it down to the bottom and make the power positive. So I'll just show you what that looks like. We're going to put the 3 and the a on the top, but now their powers will be positive. The 4 is going to come to the bottom and its power is going to become positive. And from there it's just a straight calculation. 3 squared is 3 times 3, which is 9, and that's multiplied by a squared on the top. And on the bottom we have 4 squared, which is 4 times 4, which gives me 16. And that will be your final solution there, and that will get you an achieved mark. If we want to check this is correct, so it's always nice to check our answers are correct so we can move on with confidence, we'll start back with the 4 over 3a all to the power of negative 2. And we said this should simplify to 9a squared over 16. Again, if I plug any value for a into this part and the same value for a into this part, they should be exactly the same because it's just a simplified version. They're the same, I should get the same result out. Let's try a equals 3 this time and see what results we get. Pulling up the calculator, let's try the left hand one first. So I'm going to put a as 3, 4 divided by 3a, so 3 times, and we're going to make a 3. And all of this is to the power of negative 2. And I get the answer 5.0625 out. And now let's do it with the right hand side. So I've got 9 times a squared, and we made a be 3 in this case. And all of that, let's just bracket that up, all of this is divided by 16. We get the exact same answer, so we know it's right. Again, this is just a checking method. This is the final answer here. That will get you your mark. Part C. Write 4 minus b plus 8c over 3c as a single fraction in its simplest form. So what we're looking at here is trying to subtract two fractions effectively. And if you forget how to do that, just go back to your basic number knowledge and that'll give you an idea. So for example, if we had 2/3 and we took away 1/3 from those 2/3, we would expect to have 1/3 remaining. As this makes logical sense to us, we can start to see what the rule is. Notice here that the denominator is the same, and when the denominator is the same, we just keep the denominator the same in the answer and we just subtract the tops, which will give us our 1 here. So what we need to do in this question is start by getting the denominators the same. We'll rewrite the 4 as 4 over 1, as this will make more sense as it being a fraction. So we've got 4 over 1 minus b plus 8c all over 3c. In order to get this 1 here to be the same as this denominator here, what we're going to do is a little trick, which is basically just equivalent fractions, is I'm going to multiply this fraction here by 3c on the bottom, and that will be the 1 times 3c will get us what we need on the bottom. But I don't want to change this in any way because I want it to be the exact same, just a different version or a simpler form. So on the top I'm going to have 3c also, and the reason for this is because 3c divided by 3c is just 1. Anything divided by itself is 1. So if this 3c over 3c is just 1 and I'm multiplying it to 4, then I still have 4. It's just a different way of looking at it, but it's going to be more useful to us. So let's start going through it. When we multiply fractions, we just times tops and bottoms. 4 times 3c will give us 12c, and the 1 times the 3c will give us 3c, and that's what we need. Minus, and we've got our b plus 8c over 3c. So we're just about there. We're subtracting two fractions with the same denominator, so we keep the denominator the same on the bottom. Then we subtract the tops. This is the tricky bit that a lot of people will get wrong. So the 12c is just 12c. What you have to be wary of is this minus is minusing the whole top. So it's minus b plus 8c. So the minus will expand into here and into here, making the positive in front of the 8c negative. So what we're going to have is 12c minus b minus 8c over 3c. And if we keep going with that, we can simplify the top, because 12c minus 8c will leave me with 4c. Got minus b, and that's all over 3c. Now you might be tempted to cancel these c's out here and here, but you can't do that as there's a minus sign. We can only cancel between multiply signs. So this is as far as you can go. And we're just going to go back to the original and check that we're right. So the original was 4 minus b plus 8c over 3c. So we're saying that this is equivalent to this. So if we put a b value and a c value into here, and the same b and c value into here, we should get the exact same answer. So let's just check that out. Let's go with a b value of 2 and a c value of 3, just for an example. We can pick anything we want, but then we've got to put the same values into here and into here. By doing this check, that will pick up on that negative you might have missed back here by not bracketing this, and it will allow you to fix it in the exam, because if you just put an answer down and go with it, it might be wrong. So let's grab our calculator. Let's check the left hand side first. So we've got 4 minus our b, which we're going to make the 2, plus 8 multiplied by c, which we're going to make 3, and that part there is divided by 3 lots of c, which we've called 3. And we get the answer 1.1111, and that keeps going, and hopefully we get that answer out on the right. Checking the right, we've got 4 lots of c, which we've called 3, minus b, which we've called 2, and all of that's divided by 3 lots of c, which is 3, and we get the exact same answer, so we know it's correct. So again, this is just a check at the end to make sure you're correct. This here will get you your mark, and that's worth a merit. Part D, factorise fully 4bx plus 2xy minus 6ab minus 3ay. So just looking at this at a start, it sort of looks like nothing's got like terms in all 4 terms. There's no squared, so it doesn't look like you're going to get double brackets. So just try and look at it in a different way. If we look at the first 2 terms here and here, and just try factorise that on its own, we do notice that there's got a common factor of x and a common factor of 2, as 4 can be divided by 2 and so can 2. So we'll start by pulling out the 2x as its common factor, and then we look at what we need in the bracket here to get back to what we had. So 2x times what would get me back to 4bx, so I'm going to need 2b. And 2x times what would get me to 2xy, so I'm going to need a plus y. Then I'm going to look at this term. These 2 terms, the common factor is a, they both have an a, and they both have a negative 3, as negative 6 can be divided by negative 3, and so can negative 3. So I'm going to pull out negative 3 and a, the common factors. And then I'll go negative 3a times what would get me negative 6ab. So I'll need a positive 2b. And negative 3a times what would get me back to negative 3ay. And I'm going to need a positive y. Right, at this point here, what you will notice is that you've got a 2b plus y right here, and you've also got a 2b plus y right here, so you can factor that out. And what's going to be left in the bracket, and if you think about timesing this whole thing through, 2b plus y times what would get me back to all of this, and I'd need a 2x, as that'll get me 2x lots of this, which is this part here. And 2b plus y times what would get me back to all of this, and I'm going to need that negative 3a. So the final factorized form is 2b plus y multiplied by 2x minus 3a. And if you want to check this one is correct, all you have to do is just do your FOIL expansion, so your 2b times 2x, 2b times negative 3a, y times 2x, and y times negative 3a, and you should get back to all of this here. And if that does happen, you know you're correct. And this one here is worth a merit mark. Part E. A rectangular box has no lid. The length of the base is 60 centimeters, so that's the base there. Its height is 1/4 of the sum of its width and length. So that's the length, that's the width, that's the height. And it's telling me that the height is equal to 1/4, and of means times, so 1/4 of the sum of the width, which is the addition of the width and the length is 60. So I have this equation here in terms of the width and the height, which we might be able to use later. And we're also told that the total area of the base and the four sides of the box is 7,400 centimeters squared. So we'll write that down. Total area. And we're going to just put an equation through for that before we put our 7,400 in for that total area. So we'll look at it in bits. We'll colour them in so it's easy to see. Let's look at the two sides first. So that side there and that side there. So we can see that the green part, so let's do the green. The green bit is going to be, so the area of any rectangle is the base times the height. And the base is W, the height is H. So W times H is that green area, and I have two of them, so I need to multiply that by 2. Plus, let's do the next one in pink or red. We need the back area and the front area. And again, these are the same areas, so we can double it at the end. So if we look at the red part that we're going to add now, area of the rectangle is base times height, so the base is 60 along here, the height is H, so it's 60 lots of H, and I'm going to multiply that by 2 because I have two of these red areas. And the last area we'll make blue, which is the bottom of the thing. The base is 60 and the height of this base is the width W. So we're going to add the blue area, which is, and remember there's only one of these ones, we don't have to double it, it's just the base, 60 lots of W. So that's the total area in terms of our width and height of the box. And we can rewrite this out. The total area we're going to rewrite in now is our 7,400. And I'm just going to simplify this bit at the top here so we can start plugging that in, because I can't solve for two variables W and H, but I can simultaneously solve these. is I've got two equations and two unknowns. So I'm going to substitute h in for what this ends up coming out as. So if I go a quarter times w, that's going to be w over 4. And a quarter of 60 is positive 15. So let's plug that. So let's just simplify it first, then plug in. So I have w times h here multiplied by 2, so I have 2 lots of w times h plus 60 lots of 2 is 120 multiplied by h, so 120h plus, and now the blue bit is just 60w. Right, now we'll start plugging in h as all of this. So next line down, 7,400 equals 2w multiplied by h, which is w over 4 plus 15, add 120, and then h we're going to replace with w over 4 plus 15. And last bit is our plus 60w. So we're going to solve for w, and then we can use that to find out what the height of the box is after that. So we'll start simplifying down because it looks a bit messy at the moment. 2w times w over 4. Remember, this is just 2w over 1, so if we times the tops, it'll be 2w squared over 1 times 4 is 4. 2w times 15 is 30w. 120 times w over 4. Remember, that's over 1, so it's 120w. Over 1 lots of 4 is 4, plus, and 120 times 15 is 1800, and then plus 60w. And you don't need to worry about these big numbers you're timesing together because you will have a calculator on the day. Right, simplify down a little bit more. 2 over 4 is a half, so it's w squared over 2. Now we can simplify these together. So I've got 30w plus 60w makes 90w. And 120 over 4 is 30. So this here is the same as just 30w. So I've got 30 plus 30 is 60w plus 60w is 120w in total. So I've accounted for that. We've added those ones together, and we've got our plus 1,800 on the end there. We can see this is a quadratic, so it's got it's got a squared term here. You've got your normal term here, your w, and the constant at the end. So we're going to bring it in terms of that and set it equal to 0, because whenever we have a quadratic we want to solve, we need to set to 0. So I'm going to minus 7,400 off that to make that 0, so then I have to minus 7,400 off this side here. That's going to give me 0 equals w squared over 2 plus 120w minus 1,800 minus 7,400. Let's check that so I don't get it wrong. We got 5,600. And we'll just do one last thing before we solve it. The half I'm going to write as 0.5 w squared plus 120w minus 5,600. And we can just go to our quadratic formula to solve this. So if we have ax squared plus bx plus c equals 0, then x will equal, in this case x is just w for us, minus b plus or minus the square root of b squared minus 4ac, and again this will be on your formula sheet, all over 2a. Plug in a, b and c into this formula and you'll get your values for w in this case, not x. if we just look here, we can see that A for us is a half, B for us is 120, and C is negative 5,600. We can either plug it in this formula or use the graphics calculator to help you solve it for you, which is the easier way to do in the exam, and you won't get penalised for it, and it will save a lot of time, so I recommend it. I'll show you how to do that. Right, go into menu, go to equations. Again, yours might be in a different spot as this is an older version, but it's the same principle. Enter polynomial, so f2, and your highest power, your degree, your highest power is a 2 here. So it's going to be 2 f1, and then put in your numbers. So I put in already A is a half, B is 120, and C is negative 5,600. Press equals one more time, and it's telling me that W equals 40, or it equals negative 280. After this, let the examiner know that W equals negative 2008 and negative 280 is not valid, as you can't have a negative width or a negative length. So the only solution that will work is this one here. So we'll just make sure we're answering what we wanted at the start. Alright, find the height of the box. And we know that the height of the box is W over 4 plus 15. And we found out that W is 40 below, so the height must be 40 over 4 plus 15, which equals 40 divided by 4 is 10, plus the 15. So the height of the box is 25 centimeters. And if you got all that out, you've just scored yourself an excellence mark there. Well done. We've finally made it to the final part of question 1, so it's going to go through that now. We need to show that 3x plus y multiplied by x minus 12y minus 2x plus y multiplied by x minus 16y can be written in the form a plus b all squared. So this is a perfect square question, or it will help if you have knowledge on completing the square to be able to do this. I'll go through the expansion first. So we're going to have to expand all this anyway and see that it goes back to a perfect square, and I'll show you an example of a perfect square in a second after we've expanded it to show you how you can tell it's a perfect square basically, and to write it into this form. So let's start with the expansion. 3x times x, we're using a double bracket FOIL, that will give us 3x squared. Positive 3x times negative 12y will be negative 36xy. Y times x is xy. And then we've got positive y times negative 12y, which will give us negative 12y squared. Right, this can look a bit confusing with the negative sign here. So what we're going to do is we're going to expand out these brackets first and then times the negative all the way through to our answer. So we'll keep the negative out the front, so that negative there is this negative sign here. And now we're going to do the FOIL of these two brackets here and put all that right here. Right, 2x times x gives us 2x squared. 2x times negative 16y will give us negative 32xy. Right, I've drawn that bracket a bit short, I'll put it at the end. Positive y times x will be positive xy, and positive y times negative 16y is negative 16y squared, and close bracket. Let's do the simplifying that we can at the moment. So we've got negative 36xy plus 1xy will give me negative 35xy. I've still got the 3x squared at the front here, and I've got the minus 12y squared here, and we're going to times this negative sign all the way through, which is just going to change the sign on everything. So we're going to have minus 2x squared plus 32xy minus xy plus 16y squared. Right, now we're going to look to simplify down again. So we'll go with our x squares first. We've got 3x squared here, take away 2x squared, which will give us just x squared, and I just tick things so I know what I've done and what I've got left to do. Negative 35xy plus 32xy is negative 3xy, then minus 1 more xy will give me negative 4xy, and I'm going to tick them to know that I've counted all them. And the last two things I haven't ticked is the negative 12y squared plus 16y squared, and that will give me positive 4y squared. So we've expanded it all, simplified it down, and we've got to get it in that form of the a plus b all squared. So this is where the knowledge of being able to complete a square will really come in handy. I'm going to give you an example over here of a perfect square and what to look for and how to go about completing it. So x squared minus 6x plus 9. This is a perfect square, and the reason I know and what to look out for, so for a perfect square, make sure there's a 1 in front of the x squared. If there's nothing there, that means there is a 1 there by default, so that's ticked. We've made sure there's a 1 in front of the x squared. After that, look at the number or the thing in front of just the x. So we've got negative 6, so halve it. Negative 6 divided by 2 is negative 3, and then square this, which gives me 9. And if the number on the end, without the x's on it, is that number there, when you halve the number in front of x and then square it, then this is a perfect square, and it can be written as the x is at the front, like so, and the bits that go here and here are half of this number, and in this case it's negative 6, so half of negative 6 is negative 3, which can be written as x minus 3 all squared. So that's a perfect square. Going over to what we have here, we're going to follow the same steps. Make sure there's a 1 in front of x squared. There is. Tick. That's done. Then I'm just going to rewrite it like this. Minus 4yx plus 4y squared. Right, we've still got that 1 in front of x squared, so that's good. Then we look at the thing that's in front of just x. So what's in front of x is minus 4y. So if I half minus 4y, I'll get negative 2y. And then if I square that, negative 2y times negative 2y is positive 4y squared. And we can see that we've got that same number at the back here. So this must be a perfect square. And just like before, to write it in its factorized or perfect square form, it's going to be that x is at the front, and then it's half of what's ever in front of x goes in the other two bits. So half of negative 4y is negative 2y. And we can write that as x minus 2y all squared, because we've got two of them timesing together of the same thing. So we needed to write it in the form of, and the question was a plus b squared. So just so we're fully in that form, I can write minus 2y as plus minus 2y. As a plus touching a negative just makes a negative, which is the same thing. So our a is x, if we match it up here, and our b is the minus 2y. So that's the final part of this video. I'm just going to do question 1 here. If you want to see more, I'll upload question 2 and 3 at a later date. and I'll try go through a video on completing the squares. I think that might be quite helpful. As again, if you don't have that knowledge, this question would be very hard to do. And that is the final question, and that's the second excellence question, or second excellence part of question 1. Right, thanks for watching.